Okay, hello everyone. So let's do some more examples about learn how to use the formula. We have this differential equation. If you want to use the formula, what is the first thing you should do? Make sure you have the standard form. That is, coefficient of y double prime is 1. So let's divide by x square the whole equation, assuming x square is not 0. Because you can't divide by 0. Y double prime minus, if you divide by x square, 7x over x square minus 7 over x, right? Y prime plus 16 over x square, y is equal to 0. Alright, so p here is negative 7 over x. So that is p. Good. So let's use the formula. Y2 is y1 integral of e to the negative p integral of x p integral of p over y1 square. Alright, so y1 is really, they have given x to the 4. Okay. So y1 is x to the 4, e to the negative, p is negative 7 over x, and y1 square is x4 square. Alright, here's the thing. Now, negative, negative, positive. Okay, what is the first thing you should do? Finish off that this p integral, the small integral. So x to the 4 times integral of 7 over x is e to the 7 natural log x, right? We can take this 7 out. So this is, well, we can 7 out. So it's actually integral of 1 over x. So e to the 7 natural log x divided by x4 to the square. So lot of students make this wrong. X4 to the square is not x to the 6. It's x to the 8. Okay. You don't add here. It's multiplication. Okay. Don't forget that. All right. So we can use the logarithmic properties and write this e to the 7 ln x term as really what? X to the 7, right? Because you can write e to the ln x is e to the ln x to the 7. We can bring this 7 to the inside, and this is actually x to the 7 over x to the 8 dx. See, it's simplifying really nicely. Okay, so x to the 4, x to the 7 and x to the 8 cancel out with leaving a 1x on the bottom. So integral of 1 over x, now we do the big integral, which is really a simple integral. 1 over x is natural log x. Alright, so this is y2, right? That's your y2. That's the second solution. So this is y2, and yeah, here I should have get x to the 4 ln x plus c, an arbitrary constant, but let's choose our c to be 0. So we get a nice cleaner simple y2. So final solution is c1 times y1 knows x to the 4 plus c2 x to the 4 ln x. So this is the general solution where c1 and c2 are two arbitrary constants. Okay. All right. So let's look at one final example. Okay. All right. This is going to be a little bit tougher. So we have the differential equation y double prime plus 9y is equal to 0, and y1 is sine 3x. So this is already in the standard form because the coefficient of y prime is 1. Okay. Then, well, we can use the formula, but what is p? We don't have a y prime term right here. It's missing. What does it mean? What is the coefficient of y prime term? 0. P is 0. Makes our life easy, right? So y2 is y1 times e to the integral of p negative y1 square. So p is 0. Integral of 0 is, well, integral of 0, which is 0, okay, or a constant, where we can say really y2, y1, we can say an arbitrary constant, okay, e to the c. When you integrate, p is 0, so if you integrate 0 you get a constant. So well, we can say the constant, we can choose our constant to be 0 for simplicity, so then it will be just 1. Okay, so we are done with that term, just 1, y1 square. Okay, so what is y1? y1 is sine 3 to the x. So let's substitute it. So y2 is sine 3x integral 1 over sine 3x square, right? So this everything square. How can we integrate this term? Well, 1 over sine means what? 1 over sine is actually 1 over sine x is actually cosecant x. Okay, so 1 over sine square is cosecant square x. So 1 over sine 3x square means this term is actually sine 3x, that is outside. Okay, integral of cosecant square, cosecant 3x square. So I use a trig identity to convert 1 over sine square to cosecant square. Okay, so we have to integrate cosecant square 3x. So by the definition, by the integral, basic integral, cosecant square integral is actually negative cotangent. Negative cosecant integral is negative cotangent. So cotangent 3x, but we have a 3, so we divide by 3. Okay, so this is what we get. All right, plus c. Let's assume c to be a constant. Okay, so all right, so here negative sine 3x, cotangent is actually cosine over sine, right? So this is cotangent is cosine 3x over sine 3x divided by 3. So sine 3x cancel out. What we really get is negative cosine 3x over 3. This is y2. So I simplified my y2 as much as possible. This is really an extraordinary problem because you have to use a trig identity. So it's a little bit tough one, but it's not a trig identity that is not obvious. Okay, so you should know what is 1 over sine, what is 1 over cosine, those things. Okay, all right. So we know y2, y1 was sine 3x. Okay, so we can write the final solution. Y is c1 sine 3x plus c2 negative cosine 3x over 3. So this is our general solution for the differential equation. Okay, all right. Okay, then yeah, thank you very much.